If you put it where the sun is, it would loosen up to the circle of Jupiter, a monster totally shaky and going to explode. They are among the most prominent impacts of radio energy in the entire universe, delivering more energy than a billion suns. Bug Jew, or frightening crawly Jew, is a red Goliath star. If you put it where the sun is, it would connect with the circle of Jupiter, monstrous, completely unpredictable, and about to explode. When we consider stars, we most likely imagine little glowing things in the night sky. Essentially, this is how we see them from down here on the planet, but stars are something completely different. Actually, one of the most prominent stars, Betelgeuse, is much greater than our sun. For a very long time, this star has confused analysts, but recently, something more upsetting has been happening with Betelgeuse, making scientists and other well-educated individuals incredibly concerned. Join us in this video as we explore the marvelous new findings about Betelgeuse, its approaching obliteration exactly as expected by the James Webb Space Telescope, and how this new discovery will impact our universe and our lives here on Earth. As explained by physicist Michio Kaku, Betelgeuse is a huge marvel, a gigantic star that has fascinated astronomers for such a long time. A Greek astronomer named Antonius was the first to discover it. This star is so giant that it can be viewed in the night sky from Earth, particularly during winter. If you're into cosmology, you've probably seen or heard of this star. The blushing orange star marks the upper left shoulder of the Orion constellation. So, you see, this star is ancient and, so far, quite possibly one of the most brilliant stars in the night sky. But one thing about Betelgeuse's brightness is that it doesn't stay consistent. Rather, it varies. This change is one of the great properties of the star, but it isn't the only one we should investigate. Some of Betelgeuse's specific properties are fascinating. The majority of the stars you see in the night sky are far from Earth. The closest star is 4.2 light-years from Earth. In case you don't perceive how the term light-years gives a sense of distance, picture it this way. Consider moving at the speed of light for a whole year. It's been shown that light can cover a distance of 186,000 miles per second. Thus, the distance light can cover in a year is comparable to 1 light year. Expecting you crunch the numbers, you'll have billions of miles. So, when we say the closest star is 4.2 light years away, it means it is billions of miles from Earth. Anyway, contemplate this. Some stars are significantly farther, and Betelgeuse is one of them. Betelgeuse is found around 600 light-years from Earth. So if you somehow manage to go to it at the speed of light, it would still take 600 years. We can't move that quickly, not even our fastest space rockets. Yet this star can still shine so brilliantly in our sky. If you're considering how Betelgeuse can be so brilliant regardless of its distance, that's a result of its unique qualities like size and brightness. Betelgeuse is multiple times greater than our sun. Its radius is acknowledged to be on different occasions that of the sun. Tragically, it appears as a disk in space when using modern telescopes, while various stars show up as little points of light. This is thought to be an effect of the reactions at the outer layer of its atmosphere. With regards to mass, Betelgeuse weighs around 12 to 19 solar masses. A solar mass is the standard unit of mass used by space experts. One solar mass is comparable to 2 times 10 to the power of 30 kg. Scientists can't choose the specific mass of Betelgeuse because there are no other planetary bodies circling around it to compare it with, and obviously we can't measure it directly from here on Earth. However, this makes Betelgeuse, at least on different occasions, heavier than our sun. The brightness of Betelgeuse goes from magnitude +0 to +1.6. In more common terms, Betelgeuse is on numerous occasions more brilliant than our sun. No surprise it was nicknamed a red Goliath. However, the brightness of Betelgeuse doesn't stay consistent. It fluctuates. This change is due to its pulsations. In other words, Betelgeuse grows and contracts. When it develops, it gets brighter. When it contracts, it dims. This cycle can endure for 10 to 100 days or even significantly longer. A novel property of Betelgeuse is that its surface is covered in dark magnetic spots. The magnetic field here is far more grounded than at the typical surface. Anyway, the downside is that these strong magnetic spots frustrate the flow of hot gas to the star's outer surface, making the star cooler in these regions. The fact that Betelgeuse has so many of these spots compared to our sun makes sense of why it is cooler than our sun. regardless of its size and brightness. The Sun also has its own dark magnetic spots, but those on Betelgeuse are much larger and significantly more numerous. To give you an idea, the spots on Betelgeuse can be twice as large as Earth. Betelgeuse also boasts a magnetic field that is on different occasions more grounded than that of the Sun. This field is the reason that, when seen through a telescope, the gases on the outer layer of Betelgeuse appear to be in circles or curves. Betelgeuse has a surface temperature of around 3,500 K. This low temperature contributes to the low energy radiated by the star and its weak red tone. Betelgeuse is a red star, but it wasn't always red. It was yellowish around 10 million years ago, much like our Sun. Over time, the color began changing to orange, red, and then, around 100,000 years ago, it slowly started transforming into the red star we know today. This fact has led scientists to believe that the star is maturing. Betelgeuse produces as much as 100,000 times more energy than the Sun. It would have been a furious contender to Earth's Sun if it weren't so far away. The fact that Betelgeuse, which is 600 light-years away, can still be seen and related to the naked eye around evening time is extremely striking. Our Sun is only 8.3 light-minutes from Earth. That's why it's so strong. If Betelgeuse were just somewhat closer, we would also be able to see it during the daytime. But if it were to replace the Sun, it would consume or displace the Earth and the other 4 planets near it because of its gigantic size. Besides, regardless of whether it were to match the Sun in size, it would still discharge more radiation. Betelgeuse, also known as Bug Jew, is a very giant star located in the constellation Orion, about 600 light-years from Earth. Its gigantic size is one of its most striking components. It is multiple times greater than our Sun in terms of radius and could easily incorporate the circle of Jupiter if placed at the center of our solar system. This legendary size allows Betelgeuse to appear as a disk instead of a point of light when viewed through powerful telescopes, in contrast to most other stars. Despite its gigantic size, Betelgeuse isn't the most enormous star. Its mass ranges from around 12 to 19 times that of the Sun. This variation in mass estimates is due to the challenges in precisely measuring the mass of stars that lack companion stars or other objects to provide gravitational reference points. Indeed, even at its lower estimated mass, Betelgeuse remains a huge celestial body. The brightness of Betelgeuse is another key characteristic. It fluctuates consistently over time, with its brightness going from magnitude 0 to plus 1.6. For comparison, a magnitude 0 star is about 2.5 times brighter than a magnitude plus 1 star. At its brightest, Betelgeuse can ultimately be up to 1,000 times more brilliant than our Sun. This fluctuation is ascribed to its pulsations, intermittent expansions and contractions caused by internal cycles within the star. When Betelgeuse expands, it becomes brighter. When it contracts, it dims. These pulsations can last for months, adding to its dynamic appearance in the night sky. Betelgeuse's surface temperature is relatively low for such a large star, measuring around 3,500 Kelvin. This gives it a distinct red color, typical of red giant stars nearing the end of their life cycles. Like other red giants, Betelgeuse is in the late stages of stellar evolution. It has depleted the hydrogen fuel in its core and has begun fusing heavier elements. This fusion process produces energy and causes the star to expand outward. The star's atmosphere is rich in complex physical phenomena, displaying dark magnetic spots on its surface where the magnetic field is stronger than the surrounding areas. These spots prevent the convection of heat, leading to cooler regions on the surface. Despite these cooler spots, Betelgeuse remains a massive, vigorous star, but it will eventually meet its end in a spectacular supernova. Betelgeuse is an enormous star approaching the end of its life, and its possible fate will be a dramatic one. When it runs out of fuel, it will undergo an extreme process of fusion, turning heavier elements like helium and carbon. This will cause the star to expand to possibly much greater sizes, making it one of the largest stars in the night sky before it dies in a cosmic explosion, a catastrophic blast that marks the death of a massive star. The power of a supernova is strong enough to briefly outshine an entire galaxy. This phenomenon could potentially send shock waves through space, and it's possible Betelgeuse will do just that once its time has come. It's an event that will likely be visible, across great distances, and astronomers are closely monitoring it for any indications of an impending supernova. Betelgeuse, a red supergiant located in the Orion constellation, is a remarkable star for many reasons, not just because of its size and brightness. This stellar giant is at the end of its life cycle, and understanding its behavior helps astronomers learn more about the eventual fate of stars like our Sun, which will also go through a red giant phase. But unlike our Sun, Betelgeuse is massive enough to end its life in a spectacular, violent way, via a supernova explosion. One of the most intriguing aspects of Betelgeuse is its pulsating nature. The star isn't a steady light source. Instead, it undergoes periodic expansions and contractions. These pulsations cause variations in its brightness, which fluctuate over a period of days, weeks, or even months. This is a characteristic of stars in the red giant phase, which are burning through their fuel and undergoing dynamic changes in their internal structures. The process that causes these pulsations involves the star's core, where fusion occurs. As it exhausts its hydrogen fuel, the core contracts while the outer layers expand, leading to changes in luminosity. Another striking feature of Betelgeuse is its magnetic field. Unlike the Sun, whose magnetic field creates sunspots, Betelgeuse has an incredibly strong magnetic field that distorts the flow of gas in its outer layers. These magnetic spots are vast, some being up to twice the size of Earth. These spots can prevent the gas from circulating properly, leading to cooler regions on the star's surface. In a sense, these magnetic anomalies create a chaotic environment on Betelgeuse's outer surface. Despite the lower temperatures in these regions, the star remains incredibly luminous due to its immense size and energy output. Betelgeuse is not just an ordinary star. It is a primary example of how stars evolve as they near the end of their life cycle. Stars like Betelgeuse begin their lives as much smaller, stable bodies that burn hydrogen for fuel in their cores. As they exhaust their hydrogen supply, they swell into red giants, burning heavier elements and going through rapid cycles of fusion. The core of the star contracts as it burns these heavier elements, and the outer layers expand due to the energy produced by fusion. Betelgeuse's size and erratic behavior are signs of the ongoing processes within its core as it prepares for its eventual demise. Scientists know that it will eventually run out of fuel and no longer be able to sustain the fusion processes that keep it shining. This will lead to a supernova, a powerful and destructive explosion that will release an enormous amount of energy into space. Astronomers closely monitor Betelgeuse to try to predict when this supernova might happen. The fact that it is nearing the end of its life cycle means that it could explode at any moment, though it might take tens of thousands of years for the explosion to occur. Some scientists believe that Betelgeuse could even be on the brink of this supernova event, though we are still not sure exactly when this will happen. The explosion would be so intense that it could briefly outshine the entire galaxy and be visible from Earth during the daytime. When a star like Betelgeuse reaches the end of its life, its core will collapse under its own gravity, triggering the supernova explosion. This explosion sends shock waves through space, and the energy released is so great that it can create new elements, which may eventually contribute to the formation of new stars and planetary systems. The study of Betelgeuse is important for understanding the life cycles of massive stars and how they influence the universe. These stars are responsible for creating heavy elements like gold, silver, and uranium through the process of nucleosynthesis during their lifetimes. When Betelgeuse eventually explodes, the elements it has produced will be scattered across space, potentially enriching the interstellar medium and contributing to the formation of future stars and planets. This cycle of birth, life, and death is a fundamental part of the universe's ongoing evolution. Betelgeuse is also a prime candidate for helping scientists understand how magnetic fields work in stars. While the Sun's magnetic fields are well documented, the extreme magnetic fields observed on Betelgeuse are still not fully understood. The sheer size and power of Betelgeuse's magnetic field make it an interesting object of study for astrophysicists trying to understand how these fields influence the behavior of stars, including their light emission, gas circulation, and overall stability. The star's erratic brightness and magnetic spots present a different picture compared to the more predictable behavior of our Sun. This comparison is crucial for understanding the variation in behavior between stars of different sizes and ages. As Betelgeuse continues to evolve, Scientists are able to use its behavior as a natural laboratory to study the processes occurring in other massive stars. Though Betelgeuse's fate is sealed, its study will continue to provide valuable insights into the mechanics of stellar life cycles. By observing how this supergiant behaves in its final years, astronomers can refine their models of stellar evolution and improve our understanding of the universe's past and future. The eventual supernova explosion of Betelgeuse will not only mark the end of a massive star, but also a significant event in the life of the galaxy. This explosion will release vast amounts of energy and matter into the surrounding space, contributing to the creation of new stars, planets, and even potentially life elsewhere in the universe. The remnants of Betelgeuse, possibly forming a neutron star or even a black hole, will be a source of study for astronomers for many years to come. And as we watch the star's final stages, we are reminded of the incredible power and mystery of the cosmos.